Okay, I'm solving example number 2 on page 156. We did 3 problems yesterday. Yes, on page 156 we did 3 problems. I think I did 2 of them and I asked you to do the third one. This example is the next problem, and this is about rolling 2 6-sided dice together. So when you have single die and you know that it has 6 faces like this, you can see 3 faces and then there are 3 more faces behind. You can't see them from this side. And the numbers are marked like this. You have 1, 2, 2 I think is at the back of this, but I'm not considering those things. I'm just giving you an example. This is a kind of die. And if you got 2 of them, you got another one. And same thing with this. Okay, for this die, what's the face at the top? How many dots do you see at the top face? 5. And same thing here, right? So the situation right now is that this die, it has face number 5 at the top. That one also has face number 5 at the top. But if you randomly just you roll them, it's not always possible that you will have the same face at the top. They can end up having anything at the top. Can you think about how many different possibilities are there? When you have 2 dice, you roll them, how many different combinations like this are possible? 5 and 5 is just one combination. When you have the same number at the top, 5 and 5, you can write this as 5 comma 5 in a bracket. This means this is one outcome when you roll 2 dice. What are other possibilities like this? Think about it. You may have something like this die, it has face number 1 at the top, and this one has face number 5 at the top. How will you write this situation? You write it as 1 comma 5. It shows you that this die got face number 1 at the top, the other one got face number 5 at the top. So how many different possibilities are there? 2? I already gave you 2 of them. Why do you say 2 only?
6.
6? Okay, so what are the other 4? Sorry? 5 and 5 is already given.
2 comma 1.
Okay, so 2, 1. What
3,
else?
3. 3.
3, 3. 3, 3 means this die has 3 at the top, that die also has 3 at the top. That's called 3, 3. What else?
6, 1.
6, 1, okay. So this one will have 6 at the top, like this. And this one has 1 at the top. This is called 6, 1. What else?
3, 1.
3, 1, okay.
5, 6.
5, 6.
4, 1. 4, 1.
4, 1.
4, 3.
Okay, 4, 3.
4.
2, 4. You said 6 only. We got how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We already got 10 of them. And you are still thinking. How many more? Just keep thinking. Sorry?
5, 3.
5, 3.
5, 4.
5, 4.
5, 2.
5, 2,
6, 2,
okay, 6, 2,
4,
hmm?
6, 4,
6, 4,
6, 3.
6, 3. Something comes to your mind? Is there a pattern to write them?
Yeah.
What is the pattern? This is just thinking randomly. It doesn't make any sense. You will just keep thinking when you won't have a perfect thought. You might miss some of the outcomes. So what's the best way to do it?
Just write 1, 2.
Yes, start off with 1. Let's say,
1 to 6.
oh yeah, let's say that this die, it has got face number 1 at the top, and you will have different combinations. You don't change this one, but you keep changing that die, right? So you will have this combination to begin with. You can have 1, 1, then you can have 1, 2, then 1, 3, 1, 4, 1, 5, 1, 6. Then you start with 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And in all of them, the first number that we have written, the first number belongs to this die. The second number, all the second numbers, they belong to the other die, right? Now, this was with 2, now with 3. When this die has 3, that one has 1, so you will write 3, 1. When this has 3, that has 2, you write it as 3, 2, and so on. 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Then with 5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. And the last one is with 6. 6, 1, 6, 2, 6, 3, 4, 5, and 6. So how many combinations do you see? 36. 6 times 6 is 36 different combinations are possible. That means when you roll 2 dice together, you may have one of these 36 different combinations. You can get any one output of these 36 when you roll the dice just once together, right? The question is, if you now read the question, example number 2, question number A, it says, what is the probability of rolling doubles with 2 standard 6-sided dice? What do you mean by the doubles? Sorry? Same numbers, yes. This is a double. Double means both the dice got the same number at the top. This is a double. This is a double. This is another double. You got this double and this double. How many doubles do you see? 6 doubles. And how many total number of events are there? 36. So what's the probability of getting doubles? What do you write? You write the number at the top. How many times this event happens? It happens 6 different times. And how many total number of outcomes are there? 36. 6 out of 36. That is the probability of having doubles when you roll 2 dice together. Just once. Okay? But you need to simplify this. 6 over 36, you can divide both of them by 6. This will give you 1 to 6. So this is the probability of getting a double when you roll 2 dice together. And you write it in words. This is called 1 out of 6. You can also write it as a decimal. So you can use your calculator to divide it. What's 1 divided by 6?
16%.
What's the exact number? 0.16, then what's the next number?
6.
Yeah, so it's not 16%. 0.166. If you want to remove this 6, that means this should change into 7 because this number is more than 5. 5 or more than 5. So this will be written as 0.17. And 0.17 is the decimal answer. You can write this number as 17%. You multiply this number with 100, that will give you the percent, 17%. So these are your 4 answers. The probability given as a fraction, 1/6. Same probability given as words, 1/6. The same probability given as a decimal, 0.17. The same probability given as a percent, 17%. So you can say that when you roll 2 dice together, there are 17% chances that you will have the same number at the top. Or there is 0.17 probability that you have the same numbers at the top. Or there is 1/6 chances that you will have same number at the top. Or you can say the probability is 1/6. Same answer written in 4 different ways. Got it? Okay, that was part A of this example. Now look at part B. In part B, he's asking, well, a player is playing a board game. If she rolls doubles on her first turn, what's the probability that she will roll doubles on her second turn? Now think about yourself. I give you 2 dice and you roll them together. What were your chances of having doubles? You had 17% chances of having doubles, right? Now let's say you are done with your turn and I ask you to do it again. You again pick up these 2 dice and roll them together. What are the chances that you will get doubles again? Is that chance going to change?
No.
No, it's going to be the same. Because it does not depend what you got in the last turn. It doesn't matter you won or you lost. The second attempt is independent. It has nothing to do with your previous attempt. It's not dependent on your previous attempt. It's all independent. So the second attempt you will have again 17% chances of having the doubles. So your answer to this part is again the same. Why is it so? Because your next attempt does not depend on your previous attempt. Right? If you compare this question with another one, let us say you have a pack of 52 cards. And you know that there are 26 cards that are red in color and 26 cards that are black. Right? You have a pack of 52 cards and let us say this is a pack and I ask you to pick up 1 card randomly, just 1 card. And I'm interested in finding the probability that the card that you are drawing from that pack is going to be red. What's the probability that the card that you draw from a pack of 52 cards is going to be red? How many red cards are there? 26. And how many total number of cards? 52. 26 out of 52. When you divide them, this will give you 1/2. There are 50% chances, 1/2 is 0.5, which is same as 50%. There are 50% chances that the randomly drawn card will be red. Now let us say that the card that you picked up, we don't know it was red or not, but you don't put that card back into the pack. So you got that card, you put it away. How many cards are now remaining there? 51, because you took 1 card out already, right? So there are 51 cards remaining. And let us say now ask you to find the probability that the next card is going to be red again. And you can say that the previous card was not red. It wasn't red. So how many red cards are still there? 26, because the previous card was not a red card. I'm just considering it, right? So you got 26 red cards still there, but what's the total number of cards now? 51. So what's the probability of your second attempt having a red card? It's 26 divided by 51, not 52. Because now total number of cards are not 52. You didn't put that card back into the pack. In this case, the probability of second attempt is not independent. It depends on the previous one, because this number has changed, right? But this is a different case. Here the previous attempt does not depend on the next attempt. That's why our answer in the second attempt, if you roll these two dice together again, your answer is still going to be 17%. So you will see some of the problems, the next attempt will depend on the previous one. Some others, it won't. You will have to think about it. Right? Okay. Turn your page and go to page 158. And this is build your skills problem number 4. Read the question. Alfred rolled a die twice. So you got a single die now, not two dice together. It's single die. You got just one die. But you are rolling this die twice. That is just like rolling two dice together. You're rolling the single die twice. Okay. The first time it landed on 5. So when you do, let us say you roll it once and it landed with a 5 at the top. It's given that he rolled it and he got a 5 at the top. What's the probability that the second roll will land on 5? So when you roll this die again, do you think that the output in your second attempt will depend on the previous attempt? No, it's independent. It's not like a pack of cards, it's a die. You do it once and then you do it again. The second attempt, what you are going to get in the second attempt does not depend on what you got in the first attempt. It's independent totally, right? So you do, let us say you roll this die again and you have to find what's the probability that you will get a 5 again at the top. It's 1 out of 6 again. The probability of getting a 5 is 1 out of 6 because the face that has 5 dots is just one face. And how many faces are there for this die? 6 faces, right? So the probability of getting a 5 is 1 out of 6. This is how many faces does have these 5 dots? It's just one face. And 6 is the number of faces in total. This is one face that has 5 and this is all the faces. That's how we find the probability. So getting a 5 has this probability 1 out of 6. And then you can write it as a decimal, which is 0.17. You can write it as a percent, which is 17%, or you can write it as 1 out of 6. They are all the same answers. Okay, the next question, number 5. Read the question. A family consists of 3 children. If the first 2 are boys, what's the probability that the third is a boy? Okay, do you think that the outcome of being a boy and a girl, does it depend on the previous child? It doesn't. It doesn't, because you don't know what your parents or you are going to get next, right? So the outcome of the next event doesn't depend on the previous one. So if there are 3 children in total, what's the probability that the third child will be boy or girl? It's equal probability. You don't know. It can be boy, it can be girl. It doesn't depend on the younger children, right? So what's the probability of getting a boy or a girl? A boy. The third child is a boy. So PB is 50%. Can be a boy, can be a girl. It doesn't depend on the younger
I don't
children.
have page 158.
Sorry?
I don't have that page.
Really?
Yeah.
Oh, I made photocopies for you where you left yesterday. Okay, the next one, number 6. And you have to complete this because you can write it as 0.5 or 50%, or you can say 1 out of 2. They're all the same answer. The next question, number 6. What's this name? UNA.
You know.
Yuna? Okay, have you ever heard this name?
Yeah.
Really? Oh, I've never heard this before. Yuna, I would say Una. Because there is a city in India named Una. I would say that. Okay. Yuna used the spinner below and it landed on a heart. Let me draw the spinner first. It's the same spinner that we used yesterday. It has got, I think, 10 different options. 1, 2, 3, 4, 5. Yeah, it's got 10 options. One, 2, 3, 4, 5. Yes. And this is a triangle. This is a star. I now know how to do it. No. Yes. Okay. Then circle, heart,
Star.
star. Next one, okay. Square and triangle.
Star.
Star again.
Circle and heart.
Circle and
Heart.
and there's a spinner at the top. You are going to rotate and the spinner will stop. The pointer will stop at maybe one of the options. So now read the question. Yuna used a spinner below and it landed on a heart. If she spins it again, what's the probability that it will land on a heart again? Do you think that the previous output will matter when you do it again? When you spin the spinner, do you think that the next output is going to be based on the previous one? Do you think so? If I spin the spinner and let us say I got a triangle, if I do it again, do you think that the next output, the next outcome will depend on the previous outcome?
No.
No, they're independent. It doesn't matter what you got in the previous one. So what's the probability that it will stop on a heart? The probability of having a heart. How many hearts do you see?
2.
And how many total number of options are
Divided by
there?
10.
Yes, it's 1 out of 5. And then you write it as a decimal, which is 0.2 or 20%. Right? And now the next example, number 3. Okay, read this question. It says Louise is playing a card game and she draws one card from a standard deck of playing cards. Then without replacing the card, draws a second card. So you got a pack of cards and you know that this pack got 52 cards in it. You draw one card and then you don't replace it. When you draw a card, you will have 51 left. Right? You don't replace them. You have to find in part A, what's the probability that the first card drawn is an ace? So when you draw, you have 52 cards initially and you draw a card. What's the probability that the card that you drew is an ace? What's an ace? What's an ace?
Correct.
Sorry?
Ace card.
Yeah, so what's written on the ace? A. And how many cards do you have in your deck of 52? You have got 4 aces, right? Because there are 4 different colors and we talked about them yesterday. You have 2 red colors and 2 black colors. And I also drew the shapes yesterday. I'll do it again. The red one of them is diamond. What's the other one? Heart. And then you got spade. It looks like,
Upside down.
yes, like this, right? And then you have what's club? Looks like this.
Is that pretty cool?
Sorry? Yeah. And each of them, they are 13 in number. That's how you got 52 cards in total. And each of them will have an ace. So this one has got an ace, A. So you got 4 different ace cards. You have to find what's the probability that the card that you drew is an ace. How many aces do you have?
4.
4. And how many total number of cards are there? 52. So that is the probability of getting an ace when you draw a card out of 52. And this will be, you have to write it in simplest form. You divide this by 4, you get 1 out of 13. So this is 113, 1 out of 13. You can write it as a decimal. When you divide it, you get 0.077. 0.077. And this will be equal to, if you multiply this by 100, it will give you 7.7%. So these are your 4 answers. This was part A. You drew just one card and you found the probability that the card that you drew was an ace. Now in part B, on her second draw, again remember that the card that she drew, she didn't replace it. That means you will now have only 51 cards left. If you put that card back into the deck, you will again have 52. But she didn't replace it. Right? So you now only have 51 cards in the deck remaining. On her second draw, the number of cards in the deck has changed. And you have to find what's the probability that the second card is a 2. What's the probability that the second card that you draw will be a 2. How many 2s do you have in all of them?
One each.
One each, that's 4. You got 4 2s, right? And this is how you write it. The probability of having a 2. You got 4 2s. And then how many total number of cards do you have?
52.
Not 52.
Oh, total number of
51, because you drew one card already in the previous attempt. So you will now divide it by 51 because this now depends on the previous one. It's an instruction given to you that she didn't replace the card. She did not put the card back into the deck. You now have 51 cards left, right? So the probability of having a 2 in the next attempt will be 4 out of 51. And you can't simplify it any further, that's your answer. You can write it as 4 out of 51. You can write it as a decimal. It will be 0.078, 0.078, or it's 7.8%. I now want you to build your skills problems 7, 8 before you do your next assignment. So try these 2 questions, 7 and 8, and then you can start your next assignment.
This one? Next one, 22.
I think so. Is it on page 160?
Yeah.
Yeah, that's your next
Next
assignment, 22.
Okay.
But before that, make sure that you do question number 7 and 8 of build your skills problem.
Okay.